Everyone, good morning, good evening, good afternoon, depending on the location you're in. So let me share my screen. Hey, can you see my screen, Katie?
Yep, you're good.
Okay, perfect. Hello, hi there. So today we're gonna talk about the application security in the cloud. It's an interesting attack area where it's getting attacked the past 5 to 10 years. No, interestingly. So we're going to cover that today and then see how Prisma new capability is going to solve that and then provide some insights around that area, basically. So to start with, so engineering is increasingly so fast-paced and it's more dynamic and influential across organizations. So with that, the AppSec also needs to be evolved, right? So as of today, agile development methodologies, primarily CI/CD pipelines are the commonplace in this modern cloud-native development landscape. But these technologies, right, the CI/CD pipelines are outside of the purview of the traditional AppSec programs, and the attackers are taking note of this. And the CI/CD pipelines are now viewed as a relative easy target by the cloud threat actors, right? So what is a CI/CD pipeline? So CI/CD pipelines generally are responsible for a wide range of mission critical workflows. It includes the checkout of the code, the build process, getting the artifacts. The artifacts can be an images which needs to be published to an artifactory, or the image needs to be published to a registry. And then within the same pipeline, you will be doing integration tests, unit tests, and you will be doing security scans within the pipeline, and then you'll be deploying that to the staging environment and then to the production environment if it's a mature pipeline, right? So it has a lot of mission critical workflows included within this pipeline. Because of this mission critical workflows within the pipeline, it has access to sensitive information, especially secrets, right, which are generally mostly overlooked by the security teams. So for these reasons, cloud attacks targeting engineering environments have grown rapidly, both in the magnitude and the severity, right? So that's what we're going to cover today. So we're going to try to see how we're going to protect the CI/CD pipelines and the cloud native deployment surfacing around this CI/CD pipelines, right? So go to the first slide. So what are the challenges, right? So what's the challenges today in the modern application security? And we're going to highlight some of those, right? So recent incidents make it very clear that a single unsecure step in your CI/CD pipeline have outsized impact on your organization, right? So some of an examples are in 2021, the PHP incident, right? So that's the biggest one. So what is a PHP incident, right? So on a very high level, there is an attempt to compromise the PHP code base. As you know, as of 2021 statistics, 79% of the websites on the internet are PHP is used, right? So to develop the websites on the internet, and the PHP code base got compromised. So there are two malicious commits which were pushed to the official PHP Git repository. Somehow PHP has their own Git server. So two malicious code commits were being pushed. The name of the push was, it says fix typo, right? Which is which is really interesting there, right? And generally, any approvers will think, okay, this is just a typo within the documentation or on a function, and then they'll go ahead and approve it, right? That's how they. It's a minor typographical correction, but it was somehow merged it out, and it has a RCA backdoor implanted on that code, right? So that's one of an example on that. So similarly, there is a leaked customer secrets, like the code Kovac incident. So code Kovac incident is, it has a bash uploader script. Basically, once the Kovac is finished, it will upload those reports, right? To upload the reports, it uses a bash uploader script. And based on the investigation, forensic investigation results, so somehow the attacker got unauthorized access to the Google Cloud Storage key, which allowed a malicious third party to alter a version of this bash uploader script, right? So that how these attackers were snipping out the secrets from the pipeline, right? So from the continuous integration to a third party server, right? So these are some of the very high level, very popular incidents which happened, which got visibility around these areas. The other incident to mention is the SolarWinds, which in which a bad actor and the threat actor used the CI/CD system to spread malware to around 18,000 clients, right? So this is a point where significant blast ready of the CI/CD based attacks. So these are some of the consequences of the cloud attacks, right? It's time to think differently about how we approach application security for cloud native apps and how the CI/CD attack surface is covered around this application security. So those are some of the challenges around I wanted to focus. And as I mentioned, it's an insecure impact of any single unsecure step in your pipeline is going to have that impact. Some of the examples I mentioned is the PHP incident where it's compromised the Git infrastructure, and some of the customer secrets got leaked out because of the bash uploader tool. And the SolarWinds is a blast radio of the CI/CD based attack. There are a lot of it, but these just to give you the level of attack it can happen around these areas. I just wanted to bring these as an examples here, right? So the primary thing is to minimize the cloud application attack surface, right? So the more you minimize the attack surface, the more secure your application, you can increase the percentage on the security level, right? So one of that is the shift left movement, where we're actually seeing more security teams. They're actually collaborating with engineers in an effort to reduce the runtime misconfigurations, vulnerabilities. While these helps the organizations move reacting to the runtime incident, it's enough to reduce the application attack surface as well, right? So, and again, we must give engineers the information they need to avoid these mistakes and to protect their environments from compromisation. So at its core, right, effective AppSec in the modern era is about maintaining an engineering velocity without compromising on the risk management, right? That's really, really important, right? So we need to maintain the engineering velocity. So we should not be bombarding the engineers with a lot of information. We need to be giving them a precise information, what and where the issue is and what needs to be fixed, right? That way they could quickly apply those patches or remediations and then push the code and then have their application secure. So there are 3 steps for an effective application security. It's basically 3 steps here. It's SIP, SOAP, and SAP. So it's security in the pipeline, and security of the pipeline, and security around the pipeline, right? Before we look at each step, it's really important to remember that engineering in general is a jungle of languages, artifacts, repos, and pipelines, right? So it's really important to preserve the relationship between these as a critical step when we are actually deciphering the attack paths throughout the application lifecycle, right? So for this reason, a security graph is really important to apply these 3 frameworks here, what we're going to talk about, right? The security in the pipeline, security of the pipeline, security around the pipeline. So let's see each step. Let's deep dive into each step and see what's covered and what's not covered, right? So what is security in the pipeline, right? So addressing an insecure code is the first step, right? So this requires mapping everywhere we store the code. It can be all languages and frameworks we use, but the mapping needs to be done continuously because to account for the dynamic nature of the current engineering ecosystem, right? We need to keep scanning the repositories continuously, because today we might not see an issue for a repository, but tomorrow we might see a zero-day vulnerability attack, and then we need to work on that, right? So you need to be scanning your repositories continuously, as periodic as possible. So as an example is Log4j, right? So one of the biggest concern was when it came out in 2021, Thanksgiving time. It's the basic simple questions, right? How many applications were impacted because of this? Do we have the data? And how many applications, where is the code coming from? Are there any pipelines which we can use to mitigate and then fix that as quickly as possible, right? So that visibility is not there at the mature level where we can get those stats at the real time, right? So this is really, really important. And we must also evaluate all the deployed security tools like the infrastructure as ISC scanning which is scanning for the misconfigurations. We have secrets and scanning, and then SAST, static application security testing, etc. And the important part here is we need to ensure the right scanner is used for each repository, right? So the reality, generally is that every scanner has its own output. So all these signals needs to be normalized for an accurate risk score and actionable alerting, right? So that is really important, not just scanning the repository, but scanning the repository with the right scanner and getting the data and then normalizing the data and then giving an accurate score is really important, because as you know, SCA is the biggest noisy tool in the market today, right? So the normalization is also really important. So that is within the pipeline, right? So we're going to secure this within the pipeline. So IAC, scanning, secrets, SCA, SAST, everything. This is considered as security in the pipeline, which pretty much most of the organizations is doing. And even Prisma has these capabilities, right? It's gonna, one of the 3 core capabilities is the infrastructure as a code, misconfiguration, scanning, secret scanning, and the SCA also. So next step is the security of the pipeline. So this is where we're going to focus more. So historically, so cloud breaches typically happen in 2 ways, right? So bad actors could either take an advantage of exposing via open pathways or SQL injections or an RCA vulnerabilities, or they can also abuse a resource, right? So these are some of the ways they can actually breach. And they could also even find a way to run a malware in the production, right? So these are some of the cloud breaches which then happens. So there are a lot of security solutions like the WAF, Web Application Firewalls, Cloud Security Posture Management, CSPM. We have EDRs, Endpoint Detection and Responses, we actually protecting against these risks. But all these technologies, or they're actually neglecting the complete engineering ecosystem, right? So how the engineering ecosystem is secure, so that is not being covered as part of the security solutions, right? The full protection to the cloud native organizations need to be resilient in the cloud. So that is what is missing. So what is the next crucial step, right? So next crucial step is implementing posture management of the pipelines. We have cloud security posture management, which is actually giving you the posture of what resources or what configurations are there in the cloud. Similarly, we need to have a posture management for a pipeline system. So what exactly is there in the pipeline? Give me the configurations in the pipeline, what stages, what steps, what secrets, give me everything, right? So that information, if you have the visibility within your pipeline, then you will be able to see where the risk is within your pipeline, right? So from source control to artifact and container repositories, attackers are actually finding misconfigurations in these systems to exploit. SCM, CA platforms, and developer workstations. These needs to be securely configured to achieve the goal of establishing and maintaining security of the pipeline, right? So source control management, it can be GitHub, GitLab, whatever source control management they're using, the CI platforms and the developer workstations. These are the 3 primary areas where the security need to be configured, right? So that's the security of the pipeline. So next is the pipeline posture management, right? So the main goal is to establish and maintain a security throughout the pipeline. We have a snapshot here, which I'm going to demo and show you in the Prisma. Under the application security, we have CI/CD risk capability here, where we're going to see the risk by system, risk by category, and also the details of the risk here, right? We're going to show all this in the demo once the presentation is done. So that's the critical step which we're going to talk about here. And the next is the security around the pipeline. So let's say we have a production environment which is connected to a CI/CD pipeline, right? So in this environment, the code and artifacts continuously flow from DevOps workstation to a runtime. But the final step is to secure this environment, which involves setting up flow control mechanisms. So the flow control mechanism is really important, right? The main goal with these mechanisms is to ensure that no single human or a machine user can directly connect or modify a cloud resource. So let's take an example here, right? So with the correct guardrails in place, a single user cannot directly connect to Kubernetes to ship a malicious code, right? Or to ship a malicious container, right? They also won't be able to directly modify any cloud resources, which would introduce a cloud infrastructure drift, right? So we need to have a proper guardrails. So this is the goal around the pipeline, right? This can be achieved only by setting up the right flow control mechanisms, right? So this final step, security around the pipeline, is to ensure that your new golden pipelines, what we are calling, isn't bypassed, right? So how would you pressure test this? How would you pressure test that your new golden pipeline is not getting bypassed, right? So the two basic questions you can ask. So is everything that is running in production is originating from the golden pipeline, right? So whatever resources are getting deployed or the resources are getting removed, depleted from your CSP, is it coming from the golden pipeline? Is origination is coming from the pipeline? Anything within, if it's not coming from the pipeline, that's not the security around the pipeline, right? So the next question you will be asking is, are we certain that no human or application can directly push code down the pipeline, right? So they needs to have checks and balances. They're pretty good guardrails which you can implement within each step. So there is no way a single person or a single user or a application or a programmatic access key can directly push code down the pipeline, right? So these are the two basic questions you could ask just to pressure test the golden pipeline, right? So this three-step model, right, security in the pipeline, which is covering all your IAC, SCA, secret, SAST, and all different types of this. And then you have security of the pipeline, and then you have security around the pipeline. This three-step model will definitely help the organizations build a scalable AppSec workflows in the cloud, right? So once the organizations achieve this optimal visibility and governance over this engineering ecosystem, it is really important to test the realistic attack scenario to measure the program's effectiveness, right? So those are the three steps which I wanted to cover here. So what's the future of the cloud application security, right? So attackers now, so as I told you, the engineering workstations is one of the area which needs to be secured, right? So that's where they're able to access the organizational secrets, and these are the crown jewels. Those secrets needs to be unlocked, right? The primary focus should also be a code to cloud observability, right? So we need to know what code is being used to deploy a resource. We need to have that complete visibility. This is really useful for detecting or investigating or responding to a risk. So when a risk occurs, we need to have that visibility. Where is this resource coming from? Do we have a code attached to that as that's an infrastructure as a code? Where is that? Where is it in the repository? Does this repository have these CM? Does it have the guardrails? Right. So these are some of the areas where it needs to be important, right? So targeting engineering workstations and code to cloud observabilities these are the two areas we are looking forward towards the future of the application security. And so once the SAP framework is implemented, right? So it is important to test the CI/CD pipeline security with different attack scenarios, right? This is called as hardening your CI/CD pipeline. So if you do a proper testing on CI/CD pipelines, you'll be able to see how effective is this program, right? So that, so we're going to jump into the OWASP top 10 CI/CD security risk. So this is coming from Cider, which is an acquisition done by the Palo Alto. So the CI/CD risk module is coming from the Cider. So they actually published this top CI/CD security risk, right? So there's a public document. I'll attach the links in the presentation. After the presentation, all the links where you can actually navigate and then read. So I would really encourage to go ahead and read this just to understand, right? So not on a very high level, to understand what top 10 CI/CD security risks are there today, right? So this document coming from OWASP has the top 10. This is coming from CIDR again. So there's each one has an explanation. As you can see, if you can just click on that, it gives you what exactly is the risk, and then it gives you the definition, the description, and the impact, some of the examples and the recommendations, right? So this is something which is really important, right? So there are top 10. So the CI/CD risk module is based on this top 10 risk here coming from OWASP top 10, right? So let's see the application security through the comprehensive functionality, right? So Prisma has comprehensive visibility, it has the technologies inventory, and then it has the SBOM, right? This is purely on the visibility side. So what Prisma is offering you, right? So Prisma is offering you a comprehensive visibility. So the visibility is based on the repository. So in a repository, how many contributors, what technologies are being used, what languages, what frameworks are being used, what pipelines are there, what are the issues within each repository. It clearly gives you that comprehensive visibility per repository view, right? So you can also look at the inventory per technologies, right? What technologies are getting used here, right? So GitHub, GitLab, and it also gives you the information where exactly that integration is using. And it also gives you the holistic view of what technologies are getting used here, right? And the software bill of materials, the SBOM, you can also generate an SBOM from the supply chain for an individual repository, and you can also download an SBOM report. It's both Cyclone DX and the CSV, both are supported. So these are the two formats you can use to download, right? So, and then the risk prevention, right? So we have the visibility, which is coming from the module, and how do I prevent the risk, right? So that's where you'll have these projects views, you'll have the code review insights, and then you'll have the CI/CD risk analysis pages within Prisma, where you could actually navigate to the individual capability, and then you can actually see where the risk, which policy is getting violated, and give the details of that, add suppression rules, enforcement rules, everything can be applied there, right? And then we have a pretty good coverage on the developer integrations, right? The two popular IDEs, VS Code and IntelliJ, both are supported. There are extensions available. You can install those extensions with your IDE, and then you'll be able to get all these details, informations there, right? And there is also remediation part after the detection. This is the code fixes. So some of the policies have a quick fix available and the code fixes available. You can simply click with a single button, you'll be able to open a pull request with all those issues. And then the developer will be able to look those fixes, and if he or she is comfortable, they'll be able to merge that to the main branch, right? So these are some of the topics which I wanted to cover before I navigate to the demo. So let's jump into the Prisma. So let's sign in to Prisma. Okay, so this is the Prisma platform. So it has multiple modules within the Prisma, but I'll be focusing today on the application security. So from the menu, I'm clicking on the settings button here, and then I have the code and build providers. So if I go here, and then at the top right corner, you have this blue button, click add. So this takes to the catalog page, right? So this is where the first step of the integration will be. So these are all the supported integrations we have today from the code repositories. We can directly have a integration with your VCS, your version control system, or the source control management. Both the GitHub on-prem and the SaaS-based versions are supported, Bitbucket and GitLab, and also Azure Repos, right? All the popular VCS are covered here. So this is the first step, right? The first step is to connect to your VCS directly. That way, the periodic scan happens daily on all the onboarded repositories. And as you can see, all the capabilities, we have IAC security, secrets, SCE, and CI/CD security. So all the four core capabilities are getting applied, right? So once the scan is done, you will be getting insights from all these three core capabilities. With a single scan, you don't have to specify, okay, only scan this, right? With a single scan, the scanner will be able to detect the file extensions, and it will present the findings based on the capability here under the categories. So on the CI/CD runs also, the integration is available. So these are the supported. We have Terraform Cloud, Terraform Sentinel, Terraform, and on-prem, both Sentinel and Runtask are supported. GitHub Actions, Jenkins, Chekhov, Circle CI, all these are popularly supported. So for CI/CD security, this is purely for CI/CD security, which I talked about earlier. So these are the two plugins you can install. One is Jenkins and Circle CI, where you'll be installing this on your Jenkins instance, and then we'll get the insights from there, right? And these are some of the IDEs we do support, and we're going to add more in the future. But as of today, these are the two popular VS Code and IntelliJ IDEs are supported where the extensions are available. So this is on the catalog page, right? And let's jump in. So once scanning is done, so how would we see the results, right? So I'm again from the menu, I'm clicking on application security. So this is where the application security menu is coming up here. So in the menu, we have two sections here. We have the visibility. This is the components of visibility which I'm talking about. And then we have the code and then the CI/CD. This is where the risk prevention happens, right? So the top section just is purely the visibility, and then the bottom section is the risk prevention. So let's jump into the CI/CD risks. As we are running out of time, I would like to cover this primarily today. So as I told you before, so this is purely coming from OWASP top 10 risks here, right? So based on these risks, this CI/CD risk will be finding out here. So again, these are the different systems which we are supporting today with a simple integration. I don't have to install anything. So with the supported integrations, you simply connect your VCS to the systems, and then we'll be able to surface the findings here, right? So on the left side panel, we have risk by system. This gives you per system what are the risks available as of today, and how many risks are mitigated. And on the right side, we have risks by category. And again, each policy has a severity level. It has critical, high, medium, low. We have 5 levels of severity. And based on the severity, the risks are categorized here. Again, these risks, the category is again coming from OWASP top 10. Right? So let's take an example here. Let's pick the GitHub system here. So let's look at in a GitHub system. So what are the issues, right? So the question is, how secure is my GitHub pipeline, right? So the entire CI/CD process in GitHub, it can be GitHub Actions. So how secure is the GitHub, right? So these are some of the findings which we have today, as there are 15 results here. And again, each risk has the name, how many events got occurred, and the severity of that risk, and then what system. And then it also gives you the CI/CD category. This is the OWASP top 10 category, which is mapping. And then if you click on that, it takes you to the OWASP documentation directly, right? So what exactly is being used, right? We have identity access management. We have inadequate identity and access management, right? Basically, if you want an explanation on what exactly the category is, it has an hyperlink taking you directly to the OWASP top 10 here. So let's look at some of the events, right? So identity access management is, let's take this as an event. I'm clicking on the risk name here. So this is how a typical delivery chain will look like, right? So you have the developer who is actually making the code, writing the code, publishing the code. This is on the IDE level. So once he commits the code to the source, this is the version control system or the source control management system, where it can be GitHub, GitLab, depending on the organization. And then you will have the build process where the build will happen. So as part of the build, it needs to pull the dependencies. It can be an external dependencies or internal dependencies coming from an internal Artifactory or the registries. And then once the build is done, the build will output the artifacts or the image where it will be published to an Artifactory or to the registry, and then you'll have the deployment process, right? So typically this is how a delivery chain will look like. So with the CI/CD risk, we're going to tell you exactly at what stage the risk is, right? So in this case, this risk is at the source level. So what is the risk, right? If you scroll down, it gives the details of the risk. It also gives you the severity of the risk, and it also gives you the risk. So the risk here is there is no two-factor authentication enabled in the VCS, right? So this is important. So it explains you what steps you need to perform. It also gives you the instructions what you need to do to enable the two-factor authentication, right? So that is again coming under the category identity and access management. You can also open events, right? It also gives you details on what organization on the GitHub, and you'll be able to look at the organization and go on from there. You can also suppress an event simply by clicking this and suppress an event. And if the event is fixed, you will be able to see the results here that it's detected when it was detected and when it was fixed. It gives you both the details when the issue was fixed. So the other category is flow control mechanism, right? This is what we talked earlier, that the flow control mechanisms are really important, right? So because main goal is to ensure that so no single human or a machine user can directly connect to or modify cloud resources, right? So controlling the flow control mechanisms is really, really important. So one of an example here is if I click on the event, the risk name here. So it explains you why, what's exactly it is. So the code owner review is not required before merging to the default branch, right? So there is no review happening here, which means a single user has the capability of publishing the code and merging the code to the default branch, right? So typically the default branches are the one where it's getting deployed to the production, right? So again, it gives you a detailed information on that. And when it was detected, it also gives you the steps you need to perform depending on the system here. It gives you a detailed information, what you need to do, where to navigate. You need to create a branch protection rule, and then you will select the branches you want. And then that's where you'll apply the branch protection rule. And then you'll check the require pull request reviews before merging this enables. So that way, without a review, the code cannot be merged into the default branch, right? So similarly, we have actively used repository lacks branch protection rules. So this is also really important. So this is also some of the scenario which is related to the flow control mechanism. So in this case, the branch protection settings are not configured on the repository, and again, it gives you the information. So this is how it works, right? So basically, it tells you where the risk is within your pipeline, whether it's the risk is at the source level or the build level or the deployment level. So within your pipeline, it gives you the risk, and also it gives you the category of the risk, right? It gives you the severity of the risk, and then it gives you what exactly the issue is, what steps you need to perform to fix that issue. And then once that event got fixed, you'll also see the event fixed time date, right? So that's on a very high level. That's how this CI/CD risk, we're going to surface those findings here, right? Again, it's per system, because individual system has an individual policies. Again, all these are coming from the policies. So we have a pretty good documentation on that, what exactly the policies are. So we have around 125 out of the box policies, which we're going to improve and add more. And these are the list of the CI/CD risk policies, which were added as part of the CI/CD risk capability. So let's take some of an example here. So we're talking about GitHub today. So if I click on GitHub, these are all the policies which are getting enforced, right? So each policy has the category and it also has the severity. You can click on any of the policy and it gives you much more detailed information on that, right? It gives you the ID, the severity, the category, what framework is, and what build type it is. It also gives you the description, the recommendation here. So you can also enable or disable these policies just to suppress this within Prisma, but on a very high level, these are the list of the policies. If you really wanted to know, okay, what policies are being used to get these findings, right? So those are the 125 policies based on the system we are getting here. So that's on the CI/CD risk. So quickly, I'll be touching the other capabilities also. So if I click on settings from the menu, go to code and security configuration. And so these are the core capabilities as of today, which we are offering as part of application security. We have infrastructure as a code misconfigurations. So again, we have 1,000+ graph-based policies and all the frameworks are supported: Terraform, CloudFormation, Kubernetes, Helm, ARM-based, Ansible, Kubernetes, right? So all the popular frameworks are supported as part of the infrastructure as a security, right? And there's a quick fix available. So some of the policies have a quick fix available, which means with a single click, the quick fix can be applied to the policy and then attributes can be applied. That way it's really fast to fix that. And the drift detection, it works with the CSPM because the cloud security posture management, the CSPM is bringing the runtime configurations, and then the application security is bringing the build side configurations, right? So now if there is a drift detected, we're going to surface those findings exactly and tell you which resource got drifted, and those also is part of the ISS configurations here. And then the second capability is the SCS, source composition analysis. So this is where we look at the manifest files within your repository, and then we'll be able to surface those findings. You can also download a software bill of materials for that repository based on the SCAs and the vulnerabilities here. And then the third capability is secrets. So this is the regex patterns we're using, and then we have high entropy models which we're using to detect the secrets. And the last one is the CI/CD security. This is what I'm primarily focusing today, but I just wanted to cover the other capabilities also, right? So where do we look at the other capability findings, right? So under the application security, if you go to the projects, so this is a projects page where you'll have the detailed information based on the capability, right? So again, we are grouping by policy. You can also group by resource if you want. So in this case, I'm going to ISMS configurations. Again, based on the capability, you have an individual view. So again, from a single repository, the repository might have ISC code. The repository might have manifest files for an SCA. The repository can have secrets. The repository can have licenses, right? With a single scan, you are getting all that information, but in here we are presenting it an individual capability, right? So let's say if you only want to focus on the ISMS configurations for a repository, so this is the tab you will be selecting. So let's look at the findings here, right? So the scan happened, as you can see. This is the resource. This is the policy which is getting violated. This is a custom policy which I wrote. Again, the custom policies, or you can also write a custom policy. You can also get the default policies, right? So let's take some of the default policies here. So this is some of the default policy S3 bucket cross region is getting violated. And if you click on that, so the right side one is called as Resource Explorer. This is where you will get detailed information on that resource, right? It gives you which repository and where this file is coming from, what is the resource name. It gives you the metadata of the details, where exactly this is coming from, right? The code path, the exact line number where the resource block is. It also gives you the tags. It pulls all that metadata, rich metadata information, which is really helpful. And if you click on the issues tab, so this is where you will be able to see what policy is getting violated. You can also click on this documentation, which opens and gives you that information, what exactly this policy is, all that information, right? A rich information on that policy. And the good thing is it also gives you a snapshot of the resource block, what exactly is a resource. So here. And you can also select what other, again, each policy you can see in the bracket, whether it's violated or if it's suppressed or if it's passed, right? So if your policy is disabled, then you will see it as suppressed. But if your policy is violated, you will see it as error. But if your policy is succeeded, then you will see it as passed. But for this resource, these are the policies which are, these are the total number of policies which are getting used. And these are some of the errors for which are getting violated. Right. So you can also, if the fix is available, as I told you, some of the policies have a fix available. There is a fix button here. You can simply click on fix. It opens up a pull request. You can apply this pull request for multiple repositories with a single click. But with a single click, you can click this. And if I click submit, that will open a pull request within my VCS, right? With the fix available. You can also remove this at any point of time. You can also suppress this. So there are multiple ways you can do a suppression. You just add a justification here. You can add an expiration date. You can suppress by resource, or you can suppress by tags, or you can suppress by repositories. Again, you can see how many resources are getting affected when the suppression rule is getting implemented. Right? So there are multiple ways a suppression rule can be implemented. Okay, and so for the vulnerabilities, so this is the SCA part of it. Again, the navigation and the layout looks pretty much similar. It depends on the capability here, right? So I think I'm running out of time, but I'll quickly cover the supply chain here. So this is the SBOM part here. So the supply chain graph really gives you the visibility here, right? So this is the organization and this is my repository. It actually gives me the detailed information on that repository, what files are there. It also gives you the entire information on the package information here, right? So let's take an example here. So if I go to Helmet, so I'm looking at the package.json file here. In that package.json file, I have Helmet as the package, but Helmet has a direct dependency of Helmet CSP and Connect 3.4, right? Again, the right side one is always called as Resource Explorer. You can expand this. You can go back to the details of the exact package, where is it's coming from, all the metadata, and you can see the direct dependencies. So for Helmet, you have Helmet CSP and Connect. There are two dependencies. But if I click on Connect, it has a direct dependency and it has a direct dependent, right? It gives you that information. So the point I wanted to make here is you might be using Helmet, which does not have a CVE, but for Helmet to work, it needs to download all these direct dependencies, right? And if MS 0.7.1 has a CVE, your package or your application is at risk, right? So you need to understand to make sure that all the dependencies does not also is clear, right? So that's the whole point I wanted to make here. And you can download a SBOM here at the top right hand corner. You have this 3 ellipse button. You click there, you can generate an SBOM. You can select the repository, and these are the 2 outputs you can select, and you can also download the materials here, right? And for SBOM, if you really wanted to download the entire org level of the findings here, so this is purely on the package level here. So this page will tell you, okay, there are 2,497 packages which are getting used in my org, entire organization. You can select the severity. Let's say you only wanted to focus high and critical, and you can simply apply those filters. You can also apply the package. So let's say you only wanted to focus JavaScript today, all the NPM, Yarn, and Power package managers. And now you can see only 48 results with a single toggle here. Okay, I really wanted to know, only give me out of 47 results, 59 are the vulnerability packages here, right? Again, the severity, I'm gonna remove this here. So with that, I have 48 results. So now you can also download an SBOM here, generate an SBOM, and it gives you all this information. So this has detailed information of the package you're using, the version, and which repositories that package is getting used, right? So this is a really good example, like the log4j, right? You can simply select the CVE here, and it gives you which repositories it's getting used, and also gives you the version number it's getting used, right? So that's really important here, which will help you. And the other part I wanted to touch quickly is the policies page, right? So again, these are the policies page where you will see all the policies, all the CI/CD risk policies, and all the other policies. This is where you will see the policies and manage the policies here. So you will go to config, and all the application security will be under subtype of build, right? So these are all the, as you can see, we have 1,000+ graph-based policies. Again, each policy you can enable or disable the policy. You have the severity. You can also write a custom policy. Simply click on add policy config. This is how you create a custom policy. You will give the name here and select the subtype, give the severity, and then click next. And this is where you will be able to write your own definition. Either you can use the code editor or the visual editor. You can simply select the type of the framework. These are the supported frameworks we support today. As you can see, you can simply click and observe. And this is how simple you can write a policy and then test it out quickly, right? You can also add multiple queries. Okay, I think I'm running out of time, but yeah, that's pretty much I wanted to cover. So primarily I wanted to cover the CI/CD risks, so which is a unique module as part of the Prisma, which is the security around the pipeline, security in the pipeline, and security of the pipeline, right? So this is the CI/CD risk, which is an area which is getting attacked, and getting a visibility around that is really important. I think that's the next step for a mature AppSec program. Okay, with that said, I'll open up for questions.
All right. Thanks, Raj. So if no one has any questions, is that the conclusion of your presentation?
Yes.